When is the last time you listened to a podcast about web development, web design, and small business and didn't fall asleep? Yes, we cover web development, web design, and small business, but like actual human beings with personalities. If you're a beginner, we're not going to talk over your head. It's more like asking your buddy for help. We have guests, we have fun, and let me tell you, these two can get off on a tangent. Ladies and gentlemen, welcome to HTML All the Things Podcast. This is Matt Lawrence and Mike Curran.
That's right, everybody. We are back, and this is the HTML All the Things Podcast. This episode is titled, Is JavaScript Really That Bad? So Mike told me prior to this episode that this is a loaded episode. He said it's crazy, it's loaded up. He was super excited about it, and I didn't even read the show notes. So I'm letting Mike tell me whether JavaScript is bad, good, in the middle. I'm sure there'll be some community, I'm going to say community fever. I'm not really sure what the hell that is. Community feedback on this topic. So if you want to learn if JavaScript is really that bad and you would like to support episodes like this, you can do so on Patreon. That's patreon.com/HTML all the things. You can also leave a review or rating on our podcast tab. Join us in our Discord server or share this with your friends. And we do have a Scrimba affiliate link. The discount code is a bit pending. So the discount details and the link will be in our show notes on htmlallthethings.com. It will give you the details, whether there is a discount, whether there is not a discount, all that good stuff. So go check that out because we do have that pending currently. But Mike, why don't you let us know if JavaScript is really that bad?
Absolutely. And honestly, okay, so just to give some background on this conversation, over the past few days, I don't know when this podcast is going to come out, but over the past few days in real life, there's been kind of a war going on between the JavaScript community, the JavaScript dev community, and the JavaScript framework community, I guess, and the Ruby on Rails / server-side rendering community. So if anyone doesn't know, Ruby on Rails is kind of like a everything included framework that allows you to build web applications using a language called Ruby. And the reason it's on Rails is because they've kind of designed a very opinionated way for you to build stuff, for you to connect a database, for you to render web pages. And that opinion is that all of your logic, everything should be happening on the server, and you should just be serving mostly HTML and CSS to your browser. And then back and forth, that communication, any sort of interaction on your website will happen on the on the client, send it back to the server, do some sort of processing, send it back to our client. That's server-side rendering, right? That's what Ruby on Rails is built on. That's what stuff like Laravel is built on. That's what stuff like Go, these backend libraries that just mostly do a lot of processing and then can just generate HTML and send it. That's server-side. And then there's a JavaScript community, like the React community, the Vue community, the Svelte community, where all that interaction, or most of that interaction, they kind of, when you click a button and something happens, a lot of that is handled on the front end, and the back end is only used when it's absolutely required to be used, right? And I'll get into when that is and what the back end and front end is a little bit more in depth as we go through the episode. But the fight here is, again, use less JavaScript, use more JavaScript, right? So the back end community wants to use less JavaScript. They hate JavaScript. JavaScript's a bad language, et cetera, et cetera, et cetera. Whether it is or not, okay? But the front end community is like, well, JavaScript powers the web, and you can do so much with it. Why are you shitting on our language? So there's a big war. And I want to kind of get in between that war and talk about what server-side rendering is, what client-side rendering is, and I want to talk about why you would want to use JavaScript, right? And then when you don't need to use JavaScript and why it's okay to kind of have a mix of both. And we'll see at the end of this what we come up with, but the idea is that you shouldn't be on either side. Both exist for a very good reason. You should know both, you should use both, and you shouldn't shit on each other's parades or whatever. They're both good language. They're both good technologies. There's plenty of back-end languages. Really, there's only one front-end language, so what are you going to do? Just to get a little bit into server-side rendering, client-side rendering, again, server-side rendering doesn't really matter what language it is. You can do JavaScript back-end stuff with Node.js. I'm sure everyone's heard of Node.js before. There's even frameworks on top of Node, like Express, Nest.js, and stuff like that make creating APIs and backend stuff easier for you. So that's all JavaScript. So you can have JavaScript on the back end, JavaScript on the front end. But a lot of people, and there's nothing wrong with this, a lot of people will use other languages, like PHP is a very classic one on the back end. That's like what Laravel is built on and what classic web, WordPress and all that was built on. You have Go, which is a newer language that's very performance, that you can do memory management in. It's a performance-based language. It's very popular nowadays for backend stuff if performance is a key metric that you want to track for a backend. You have stuff like Ruby on Rails, like I said. It's more of like a complete package that ties the backend and front end together, but is more of a backend language than anything else. You have Rust, which is a very performant backend language, even more so than Go, because it's almost like an embedded language. You're almost writing like assembly code, or C code is more likely. And you have libraries and stuff that make it a little bit easier for you to work on backend stuff, but still have a little bit of JavaScript functionality, stuff like HTMX. We had the founder on, he explained it before. Maybe we'll link that episode in the show note description. But there's a lot of different kinds of server languages is really what I want to get at. When we're talking client-side rendering, this is a simpler one to talk about because that's JavaScript. Anything that happens on the client, when I refer to client, that means you, like a user using a website, their computer, right? Like when you go to a computer, when you go to google.com, stuff is happening on Google servers, but whatever is served to you when you see that Google search bar, that's happening on your computer. If you open up the inspect element, you'll see the code right there. That's the client. You are the client. All of that interaction, all of that logic is powered by JavaScript. There really is no choice for a lot of things there other than JavaScript. You can get around this a little bit if you're using little tricks like using a post request in HTML to launch some stuff back to a server and then get the response back. Like you can get around using JavaScript in certain ways, but overall, almost any interaction you need to do on the front end that's rendering stuff is going to be powered by JavaScript, or at least part of it. And having said all that, there's a lot of hubbub about like why you should use less JavaScript, why you should use more JavaScript. And really, I want to get to a point where like, is this all because JavaScript sucks? Like, is this hubbub that people just trying to move away from JavaScript because it's terrible? Or is it because they're more ingrained in their own technologies? They don't want to learn something new and they want to just use what they already know, right? Like whether you want to lean to one side or the other, that's up to you. But realistically, that's a lot of the arguments there are about that.
I was actually going to ask how much of an argument like of this magnitude, I guess, is about real sort of technical reasons and how much of it is because of, that type of thing. Like, I don't really want to learn this. And so I'll come up with oftentimes legitimate reasons to not try it. But at the end of the day, you've come up with it because it's acting as your excuse. And sure, I get it. Like if the actual reasons are legit and you really don't want to do it, then, okay, fine. But like there is going to be sort of the people that are in the JavaScript camp. They're not going to want to learn something else. So they're going to fight or defend JavaScript, right? Fight for and defend it. And then the same thing goes for Ruby on Rails and, God knows whatever else, right? HTMX, became this big meme for a while because there were people that were super for it, super against it, all the rest of the stuff. I mean, Tailwind CSS, something as simple there where you're not really changing CSS that much. You're just sort of almost changing the interface it's kind of like you change how you type it, more or less, right? Obviously, there's some nuance there. But even then, there's people that are super for it, people that are super against it. And again, some of those reasons are legitimate. And some of those reasons they're legitimate, but they're being used as an excuse. And so it really does beg the question, you, the listener, if you're a part of this war, like where do you sit? Do you absolutely not like JavaScript? Do you absolutely not like Ruby on Rails? Or are you making, an excuse for it? Like, for example, if I was like, I know JavaScript, I don't know Ruby on Rails. For myself, if I was like, should I use Ruby on Rails? And I just sort of like find a few articles that say, don't try Ruby on Rails because we hate it. It's sort of like, that makes me curious. But at the same time, it also gives me an out, right? I have like two paths in front of me. I can say, well, what makes it good? Like, do I do that other Google search of like, what makes it good? What makes it bad? And do I dig? Or do I just take, the first two articles that I've gotten that are against Ruby on Rails and say, okay, Ruby's bad. And that's where I'm going to sit. And this can be applied totally to other things too. Like this can totally be applied to operating systems. Like I'm a Windows purist all the way through, and a lot of devs will use Macs for the designer angle, but also for functionality to an extent. But then there's people like me that will argue, well, hey, you don't even use the terminal. Like many people don't use the terminal, but they're like, yeah, but Mac is a Unix system. It's like, yeah, but are you using that, or are you just using web apps to build things, right? Or are you just using Photoshop or whatever to build things that you could also do in Windows? What's your real sort of reason? So the reason why I bring this up at all is that there's going to be a lot of nuance on both sides, right? Like so many people are going to be pissed at me for not using Windows, and I'm pissed at them for using Mac a bit, right? But at the end of the day, it's sort of like, okay, the war kind of ends, and JavaScript and Ruby on Rails still exist, and so does Windows and Mac.
Yeah, and like there are some people that are heated about it, right? Like there is a heated argument going on, and people are like legitimately calling each other out. In my eyes, both sides are reaching very hard, like you're saying, Matt, for things that are like obviously better than each other at certain things, because backend will do stuff better than front end in certain situations, and front end will do stuff better than backend situations. You have to really reach from both sides to make the point. And that's what people are doing. They're trying to make the points that they possibly can to get their points across because they're angry for whatever reason. But they are very much reaching for those conclusions. What I'm trying to get at here in this episode is that you do need both. Like you need a mix of both to do stuff on the web. Like you can't be blinded, like fully blinded into thinking that, hey, I can do this and only this in all backend. Not to say that it's impossible, because people do it, but it's just janky and weird. Like it makes no sense to argue it, is what I'm trying to say. Like you can do it as an experiment for sure, but to actually ship an application that refuses to use JavaScript for the only reason of saying that JavaScript is bad, it's just a weird take and a weird stance. And the same thing is like trying to ship a secure application, for instance, like someone's trying to make like a login system on the front end and refusing to use a back end is dumb too. Like both sides of the argument are kind of dumb if you take them very literally. But the reality is that people will just reach for stuff and find things to say about each other. And that's how all internet arguments go. And there's no exception here. Like this is a very heated debate between a couple different people, and everyone else is on the sidelines being like, that's interesting. But yeah, with that being said, I think we can move on to just talking about what JavaScript is, like how it works on the front end of things, why we use it on the front end, right? And what it kind of does for us. First of all, the web runs on JavaScript. I've mentioned it before. We talked about client-side rendering. Client-side rendering is JavaScript. You can't get around that. It's been like that since 1995. It's not going away. Like JavaScript is not going away. So refusing to accept it or use it is you just kind of coping for or hoping for something to change, I guess, or something like that. But JavaScript is here. It's been iterating for a long time. EMCA script has been around since 97 and has evolved. New features have been brought in. Old features have been taken out. TypeScript has come on the scene where it's allowed us to kind of quote unquote strongly type JavaScript, which was a big complaint that a lot of people had. There's still some issues with that. There's still ways around it. And it's still, I wouldn't say that even with TypeScript, it's a strongly typed language. No way, because there's like workarounds you can do, which you can't do in a strongly typed language. But we can institute some of those nice features from languages that maybe you're used to, like C# or Java or whatever, that you're more like a backend dev would be more comfortable in. So there's ways to make JavaScript appear better for people that maybe have hated it before. That's kind of the idea here. And it's continually evolving. It's not stopped. Like JavaScript development is continually going. We have new features being brought in like every year, every 2 years, every 3 years being proposed. And it's getting better, like web components and stuff like that. Like the web ecosystem is getting better. You need to kind of look for it. It's not like in your face getting better all the time, but it is getting better. That said, obviously, like you need JavaScript to be able to do interactivity and data management on the front end. Okay. That's where JavaScript is mainly used. Front-end development to do data interactivity or interactivity. So again, user pressing a button and something dynamically appears on a page. A lot of that is going to be handled by JavaScript. That said, the need to use JavaScript is a very contested point among the community. Again, I mentioned it before. For example, I'll give you an example of a very basic JavaScript functionality. Let's say you need to press a button on a page that will increment a counter, and then it will display a count somewhere, right? So you're just pressing a button and 0 goes to 1, then you press it again, 1 goes to 2. Very simple, a count. You can do this via JavaScript. You implement a variable in your script tag or your JavaScript file, let count equal 0, create a function that will then increment that count. All you have to do is go count ++ in that function, done. And then all you need to do in that same function is update the element that houses that number on the page. So you use something like get element by ID, make sure that the element that you have there, the div has an ID on it, and then change its inner HTML to the new number count that was after incrementing. And that's it. That's your way of using client-side JavaScript to update a counter and show it on a web page, make your website interactive, right? That's the way you use JavaScript. Now, this happens all on a person's browser. You never hit a server at this point. Everything is loaded from an HTML file or, again, maybe a JavaScript file that you send with your payload. This isn't technically the only way to do this, right? You can do this, a lot of this process on the server. So, for instance, using any server-side language, PHP, for example, you can have an increment button on a page that's regular HTML. Then when someone presses that button, instead of just doing that little JavaScript function, what you can do is send a request to a PHP server that will then take that request, and maybe with that request, you send a count variable, like whatever count is currently at. And that request can then, on the server in PHP, increment that variable for you, and then send back the new variable to your client, which will then, you can then either display using the same inner HTML, like document.getElementById, still a little bit of JavaScript, less than before, but a little bit of JavaScript to display that new information from the server, right? So now we've offloaded some of our processing, some of our functionality to the server. The question here becomes, what did you gain? Okay, so you've given the server a function, you've added complexity in the sense that now you have to manage two separate pieces of functionality. You have to run a server, which, can cost money and can take time. Or you also have to connect that, like make sure that that connection is working across domains. So you've added complexity to your application when it could have maybe been only handled on the client, right? So this is a perfect example of maybe you over-engineering something for the sake of familiarity with the language. Like if you don't want to learn JavaScript to increment a counter, a lot of times a backend developer will just implement this server to client relationship, even for a very basic interaction that could be handled on the client. This is a little bit of over engineering, but it can be done, right? You can take it steps further where, like, if you want to remove the need for JavaScript even more, you can have it. This is kind of a crazy one, but what you can do is instead of having the button be just a regular button, you can have this being a button that's part of a HTML form. And what that allows you to do is instead of having to have like a whole API connection layer in the JavaScript on the client to be able to contact your PHP server, you could just have a form button that when you press increment, it posts a request to your server, and then you can do something with that request on the way back. That will require a little bit of JavaScript. But again, the intention here, and I've seen this happen before, is like less and less JavaScript. But you're overcomplicating things for the sake of less JavaScript. I just want to be very clear here. In certain situations, that is an overcomplication, right? In some cases, that can be a really cool and neat way to interact with the server. But a lot of times, having a well-managed front-end validator that can check to see you're passing in the right information before you even send it to the server, and then you can return that information and then run it through some more validation to make sure it's displayed correctly, isn't a way you can handle it, and probably a better way in a lot of instances. This is really all a long-winded way to say that you can technically do most everything that JavaScript can do on the server, but really should you?
Well, at that point, it's a question of really like, where do you want the computing to happen, and why do you want the computing to happen there? If you have like an increment going up in like what would be something that's simple, like in a form for some reason, where you go like, oh, like how many, I don't know, problems are you having? And you just literally have like a plus button, and you're just like, oh, I'm doing a support request, and I have, two problems. You click the plus button twice, I mean, that doesn't really necessarily need to be done on the server, because chances are it's going to, when you press send or submit the form, it's going to fire off an email, right? So you wouldn't need to do just, adding like literally the number 2 into that field. You wouldn't need to do that, right? But like there are certain things that you would want handled by the server, like you mentioned, which would be authentication, because the server is sort of private. You can kind of think of it as, and like you said also, Mike, when you open up your dev tools and you inspect element, you can see your HTML, your CSS, your JS, but you can't see the PHP that's running if PHP is involved in the situation. And so you would want something kind of absconded or hidden, which would be something like a password. But also, if you think about, and the reason why I mentioned place as well, is that the server is a place to do things. So, let's just think about this outside of a website idea. So let's just say you go to like a web app, and let's just say you're using it. So we're out of the development space for a moment. You're going to OneDrive. If I were to then pick, I have a thing called like script.txt, and it's really like a script for my next podcast, right? So podcast script.txt, let's say. So I have my TXT file and I upload that. Well, it better upload to the OneDrive servers, because the whole point of me doing that is to A, back it up, but B, make it accessible on, say, my laptop. Let's say I'm working at home, upload it via the web app to the OneDrive servers, and then I'll go on vacation or something, but I still need to work on that podcast script. That better be on the server, because I'm not accessing my home computer, right, to do that. I'm not like uploading it to the OneDrive website via JavaScript. You know what I mean? Like that doesn't make any sense. So like then obviously the server's playing a role there, because I need this thing to be available. And like, what's the commonality here? It's that my desktop can access the server, and so can my laptop wherever it is when I'm on vacation in this particular example. So you really have to kind of ask yourself like when and where you want to be able to do this stuff. I will say though, as we discussed this, and this has come up in prior episodes as well, is that you can see sort of a little bit of a pattern where, JavaScript can be really seen as messy in this way, because JavaScript can, if it's used, in a certain way with Node and whatever, can be used in the back end. So it starts getting a bit like, okay, and then like JavaScript in a vanilla state is not typed. You need TypeScript. So it's like, okay, you know what I mean? Like there are certainly patch jobs that have been done, but to sort of play devil's advocate, I guess, to myself to an extent, is that when you make a general tool, in this case, JavaScript is a very versatile, or I'm going to call it a very general language, because it's very general or generic, it doesn't have these specialty things. And so you, the developer, kind of tape those things on, right? Like you add that functionality, like, oh, I'd like to use JavaScript in the back end to some extent. You actually add that functionality. I would like there to be typing. You actually add that functionality. It just doesn't come sort of out of the box. So there's certainly, some nuance there. However, I weirdly don't hear anyone screaming for CSS to be sort of fixed up. I mean, there's, standard naming conventions, standard naming schemes like BEM, for example, BEM, and a few others. And like those are something that you can choose to use if you'd like, right? Like that's another, just like with JavaScript, where you can choose to use those things, but you absolutely don't need to. Like CSS isn't going to spit out an error that says like, hey, you called this one text1, this class text1, and the other one text2. And that's too generic. No, nothing's going to throw you an error in that particular regard. So you can really kind of think of our technologies, I guess, nowadays as really just being sort of more versatile because they're going to be used in more places. They're a product of their environment. I think that if, typing was the absolute number one thing that was just absolutely terrorizing JavaScript developers. I mean, JavaScript itself gets updates. This isn't the same, JavaScript that's been around since the 90s. There's been updates to it. I think that the powers that be would say, all right, that's it. We're going to add typing to this thing. Like there's going to be some sort of typing in JavaScript, and then, some sort of legacy system to support the older apps that don't use typing. I mean, let and const, I know those aren't typing, but let and const is an example of the evolution of how we store things and how we use things, and how some things need to be const or constants and some things should be lets. And like var is still around, right? That's your sort of legacy code, but you can kind of not use var anymore as much, right? Unless there's something very specific, which I'm sure someone has an example. But more or less, many a time, all your vars can be turned into lets, and many of those can even be turned into consts, right? So like the actual language itself has actually evolved and changed.
Yeah, I think you make a lot of good points there, and like especially that it's not a perfect language, and I want to make that abundantly clear and emphasize that JavaScript has a lot of deficiencies, even compared to older languages like Java and stuff like that. Like there were decisions made early on in the JavaScript process when JavaScript was being invented that are still hurting us today, right? Language typing being one of them, for sure. And being able to support backwards compatibility for that and still requiring strong types at this point is impossible because of the decisions made in the past. So I get people's restraint from using JavaScript. I understand that they're like, it's not as good of a language as some of these other languages, that especially the newer ones like Go and Rust and all that. Sure. That doesn't stop it from being a very productive language, though. When you learn the ins and outs of JavaScript, like any other language, you can still become a very productive developer that builds fairly safe applications, right? It's, yes, on first glance, and for people that are just coming into it, again, this is coming from a lot of people that are just, building in C# or building in Go and building in these strongly typed languages in the backend and just jumping into JavaScript and being like, boom, like hit in your face. I can reassign this string into a number and no one will yell at me until it gets to the page and the page breaks and explodes and the computer runs away. Like there's certain situations that JavaScript causes from just being JavaScript, but some of that is because it is not a compiled language as well. Like this stuff happens at runtime. You write code, it doesn't yell at you that it's wrong. You open up your web page and everything's broken, right? Until you actually use it. So that is another deficiency of JavaScript. There's plenty of them. There's not a perfect language, but it's what we have. It's the hand that we're dealt, and there have been significant efforts to make it better. Again, TypeScript being one of them, the evolution of the JavaScript language being another. And there's no reason to just immediately write it off because of its deficiencies. That's really the point there, yeah.
I do have a question actually though about the deficiencies though. Is like you mentioned that the strongly typed and required typing, let's just call it that. Required typing in JavaScript can't really come down the pipe because it would break all the JavaScript that currently exists potentially, right? Depending on how it's implemented. But we assume that it would break everything. That's a fair assessment. But realistically speaking, they could add another type of variable or something like that. This is just me brainstorming on the spot, spitballing. Like they could add, this is a const, here's your old school var, and then there's also a type now. So it's like type A is a string and type 1 is a whatever. Like I'm totally making up some BS. But this is something that could potentially come down the pipe. And then the reason why I mention this is because at the end of the day, if someone's like, yeah, but like you don't have to do strongly typed and that's not safe. Sure, like if the safety net isn't there, because TypeScript itself is a compiler, right? Like it needs to be compiled. And so like the compiler will bitch at you and say, yo, like this isn't typed correctly, or there's a syntax problem with the typing or whatever the problem is, right? Whereas JavaScript doesn't need that. But like you could also argue that like if you want it to be strongly typed and JavaScript at some point adds these, hypothetical typed variables that I just said, you could actually argue it's the developer's fault at that point. Like, hey, like you're using these old ones, like don't do that, right? Or like how much is that like safety net a part of these people's argument is, I guess, my question. Like it's the entire argument is just the safety
correct
net. Because I guess they could be using TypeScript.
Yes, they don't have to, so therefore it's not strongly typed, period. Yeah, so yeah, like because you don't have to, you bring on a junior dev, they accidentally reassign your variable that you named in one file to a function, and all of a sudden your entire application breaks. No matter how much buy-in you have from your team, like the fact that it's not absolutely required means that any other developer that you bring on later, or even on your team, accidentally doing something could screw up your whole entire application without them knowing it. Because again, it's a runtime issue. Like this isn't something unless it's compiled. Like TypeScript does solve a lot of this. It is opt-in. Unless it's compiled, you don't know it until you hit it. And that has happened many times where it's just someone's mistake. And because nothing yelled at them, they just let it go into production and boom, big issues. So again, deficiencies are deficiencies. I think at some point there will be some typing in JavaScript natively. I believe in that. Maybe even a JavaScript compiler comes out. Who knows? And that would solve a lot of issues. But it will never be a strongly typed language because of the backwards compatibility. That will never happen. That's the reality we have to live with, and that's the reality we have to accept. And we'll kind of continue moving on in that direction. You have to buy into the typing, and that's what TypeScript is about. You have to set rules, and you have to also, because of the fact that TypeScript is TypeScript, you have to be able to kind of bend the rules a little bit. So I'm saying it from a person that uses JavaScript and TypeScript every day. Yes, there are issues, but once you learn to use the language, once you accept those issues as deficiencies that you can't fix, you can be a very productive developer that builds safe code. There is absolutely ways to do it. You can be a productive team lead that implements solutions to all the problems that Matt and I were just talking about, and make it so that your apps are going through a compiler, again, TypeScript, there's other ones, and make it so that JavaScript will play between the bars instead of just being a chaotic language that people assume it to be. It just takes a little bit of work, and I think that work is worth it if you're working in the front end, right? Like, okay, so moving on to this next segment here is when JavaScript makes sense. When dealing with user interaction, with the need to provide immediate, fast user experiences, JavaScript is pretty much mandatory. Like if you're building a web application where you need someone to have immediate responses to their actions, someone types in a to-do item, presses enter, and you want that to-do item to immediately appear on screen for them and not have to wait for them to, hit a server, verify everything's okay, come back to you, then show it, or open up a new page even. Yeah, you need JavaScript to make native-like experiences, right? Like the reason we have so many new web apps like Figma and Linear and all these new like crazy applications that can do so much inside of a browser and they feel like a native application is all due to client-side JavaScript. Like without it, if you're just relying on server-side rendering back and forth, you're going to have a bad experience for a lot of people, right? Like it's not just for, for fun that we use JavaScript. It's to provide a better experiences for a user. So relying only on the server can and will make for a poor user experience. If you're relying only on the server, any request you make, any button you click, like I mentioned that whole example with the button to increment, that entire thing that I mentioned, every time you click that button, there would be a call to a server. The server would have to do something, and then there would be a response back to you. That server, if you're in Australia, could be across the entire world. Now, it's still going to be fast, but there's latency there, no matter what you do, right? Like you could put a server in Australia too, that increases complexity, right? So you can spread out, you can distributed systems, that increases complexity, but you can do it and that will make it better, but it's still going back and forth in a network call. Whereas a plus plus in a JavaScript that's happening on the client, it's almost immediate. The way that the browsers are rendering JavaScript is getting faster and faster. The new JavaScript engines are better and better. It's almost immediate for a lot of things. So like utilizing that to make for a better experience is the key here, right? So I'll give an example in the to-do list side of things, right? This is an example that will incorporate a little bit of server logic because again, I'm a proponent of you have to have both. Because first of all, how would you do a to-do list without a server? Where are you going to store your to-dos? You're going to directly contact a database? No. You need an intermediary layer on the server to be able to read your to-dos, send them back to your JavaScript and stuff like that. So essentially, you create a to-do on your front end. And what you could do with JavaScript is you can immediately create that element that you've typed in as a to-do in your front end. So when you type in like, hey, I need to clean my house today, press enter. You can make a call to a server so that you could store that information on the server for next time you come in. But you can immediately show that to a client on their browser using JavaScript so that they see that, oh my God, it's like immediate response, right? This is called optimistic updates so that you're optimistically showing that, hey, I've created this. It's still going into a server and still coming back to you. But using JavaScript, you have that feedback immediately for the client. They don't care about the server connection. All they care about is everything is moving fast for them. If something goes wrong, You could easily have it gray out a little bit, show an error message when the server response comes back, but you're not waiting on that server response to do anything. You're assuming that is when it went correctly.
You're also passing the cost on, or passing it around, I should say. If you're using the computing power of the user's computer, then your server doesn't need to have that computing power available, because the availability is also really key. So if it's just you're the developer, and no one else is testing this app, and you're just sort of being like, no, I don't want to use, any client-side stuff, or I want to use virtually no client-side stuff. I want to go mostly server-side. I want most of the server the server to handle most of the load. That's just you. And so you may have a great experience, but the server only has so much availability. There's only so much bandwidth, and there's a lot to consider. Like, there's only so much RAM, right? Not to get into the computer parts, but you have to when you're talking about backend stuff. There's only so much RAM. So how good are those NICs? How fast are the hard drives, or are they SSDs? What if they aren't, etc.? And then people have to access it. I mean, there's a reason why websites, when there's like a big contest or a big event, go down, because there's too many people, right, trying to get in. And unless there's a queuing system, it's possible that the website will crash. And even when there's a queuing system, the queuing system may result in, an hour plus wait, right? And you don't want to have that, plus the latency, right? Like the hour plus wait and all that. Like, you have to consider that. But the person's computer, you can assume, is available. Now, there's caveats there, of course. Some people's computers are not good, so you have to consider that. Like a Chromebook, like a cheaper Chromebook, for example, a cheaper laptop, an older desktop, right? An older computer, an older phone. They're not going to have the computational space. You also may run into a situation where, we assume the user's hardware is available, but they may have hardware acceleration turned off in their browser. They also might have other pieces of things running. So let's say, for example, I'm rendering a video for our YouTube channel. Sure. I'm rendering that, and it's going to take 30 minutes. And while that's happening, I decide to go on Figma. Well, 100% of my computer is not available to Figma right now, right? Or the amount that would normally be allowed, because the browser has to access the actual hardware that I have, but the amount may not be as much as it was before, because some of that processing power is being used up to actually render the video. So all of these things come into consideration, and cost, for whatever reason, in this cloud hosting era, seems to always be overlooked, I find. I think a lot of people think like, it's just hosted on the cloud. It's like, yeah, but if it's not being processed on my computer, it's being processed on a computer. It's not just going into the ether and not being processed. Like, a computational load has to be computed. Like, it has to be computed. If we just think about it in the simple thing of like, if these two numbers need to be added here or in Ohio or something on a server, which is remote from me, it's like, it still needed to be done. It's absolutely just something where a lot of people just won't consider it. And especially if they're developing, they will forget that it's not just them accessing it. Like, what if 5,000 people hit the server all at once? Like, that's a massive problem.
And that's the thing. Like, it's such a balance. It depends on what you need. The server can be an extremely beneficial thing, right? Like Matt mentioned, the fact that you're able to offload stuff to the server, but the caveat there is that you're paying for that 100%. The client can also have a huge benefit of being able to offload to the client. But the caveat there is that you can't control the client's specs. You don't know what the client has. So now you have performance inconsistencies. So you need to decide what your application values most. If there's a massive number crunch, for instance, that requires a ton of processing power, okay, but is incremental to the performance of your application, like you can't live without it, and you need it to happen quickly, you have no choice but to do it on the server. Otherwise, what's going to happen is the guy with a $10,000 computer is going to have it happen in a second, and the person with a $200 Chromebook is never going to see the end of their calculation. And now you have extremely severe inconsistencies. You have bad user experience. Whereas sometimes you're a scrappy startup and you don't care that the 1% or the 2% of people using your application can't use it because you need to transcode a bunch of video, but you can't afford to transcode a bunch of video directly on your server and send it over. So you pass that over to the client. So yeah, now you're loading up the client's computer pretty heavily, but you're giving them the service that is able to whenever transcode the video and add like a different layer on top of it or whatever you're doing to the application. You're passing a lot of the costs over to the client and hoping that the client has a good computer, but you're taking that into consideration and you're understanding that it's going to cause inconsistencies. Better computer, better results. It's all very important to know when you're designing the application, when you're kind of coming up with a decision-making process of how you're going to offload to client and server. But the point is you need both. You cannot survive with one or the other and have a good experience and have a great experience. You need to rely a little bit on JavaScript. You need to rely a little bit on server most of the time. Now, there's a lot of caveats here. You can only use JavaScript if your app is pure front end. You just have a bunch of divs and you're just doing some like canvas art, whatever. Like there are certain situations where you don't need a server, 100%. If you just have a business card website, marketing website, whatever, right? Having said that, in that case, you want to rely less on JavaScript because you want it to just be HTML and static CSS to be as SEO efficient as possible. But regardless, like if it's like a local web app that you're running or something, maybe just JavaScript. But you most of the time will need both. That's really the point. To make it easier for you to build out like really good user experiences, there's really good tools available like React, Vue, and Svelte that make it easier for you to make these native-like experiences on the front end. If you kind of go away from that, again, you're going back to like serving everything from the server, and that I'm guaranteeing you that takes away from the client, from the user's user experience perspective, having to wait every single interaction for a client for a server call. I've seen it happen. And again, all of this kind of stems from the argument that DHH, the creator of Ruby on Rails, has, that he almost does everything on the server. And because of that, there are some weird inconsistencies with some of his applications. Like, hey, his calendar application has this weird loading issue if you're loading a calendar screen, because again, every interaction is happening on the server and you have to accommodate for that. Like you have to make sure that a loader appears, or you have to make sure that the div doesn't collapse in before it gets to the element that it receives from the server. There's a bunch of little things that you have to take into account that are solved by using JavaScript most of the time, or just straight HTML. Moving on here, when do you not need JavaScript, right? Like, because we've been talking about JavaScript all the time, but there are a lot of situations, we've mentioned a few, where you just don't need to use it. Now, the caveat here is you can use it. Again, Node.js. All the things that I'm going to talk about right now, you can accomplish in JavaScript. If you know JavaScript and you want to write it on the server, nothing's stopping you. There's tons of technologies there that can help you write JavaScript on the server, maintain an entire code base in one language. There's a lot of benefits. We're not going to talk about that in this podcast episode, but there are a lot of benefits in maintaining a code base with one type of code. But not a lot of people want to do that, and that's okay. If you're a better PHP developer, if you're a better Go developer, if you need the most performance out of your machine as possible, out of your server as possible, there's a lot of situations where you might not want to use JavaScript, and that's good. It's good to indicate that, or it's good to just follow whatever you like. And when to not use JavaScript is, again, when initial load matters. So what does that mean? Initial load of a website is heavily reliant on what is rendered on the screen, how much loading JavaScript needs to do when you send it when you send the client all the files it gets. So a client can get a bunch of HTML files, CSS files, and JavaScript files. Before it renders anything, you could be doing a lot of processing in the JavaScript files before it even shows up on screen. Like if you're getting data on the front end before you even show that data, like a bunch of blog posts, that all has to happen after your client receives all the files and while the screen is loading. That can be a bad user experience. Like imagine a client is running on a really slow connection. It gets all the JavaScript data. Then it starts running that JavaScript, the onload functions, and all those onload functions have a bunch of calls to a server to get a bunch of blog posts. And then, so now your client is waiting for all those blog posts to come in, and then it needs to run the JavaScript to actually display those blog posts on your screen. That can take time, depending on your connection. The better way to handle that is to do server-side rendering. So you do all the data fetching on the server, and then when the client actually gets the files, they already have all those blog posts in them in HTML. What any computer or any website, web browser can do is really quickly render HTML. That's what it's best at. So the more HTML you can give it, then the less JavaScript, it's going to be faster. And this is where initial load matters the most. It matters a lot in page speed ranking. It matters a lot in if you're building accessible systems for low income or low internet populations. Obviously, SEO is super reliant on quick interaction, or when you have e-commerce, it's also pretty important because when you click on a website, there's a lot of statistics that say, like, if you don't load it in the first, I can't remember what the actual one is. Don't quote me on the statistics, but it's something between like 30 to a minute. If you don't load your website in 30 seconds to a minute, almost everyone leaves. So you need to take all those things into account. You could be losing money if you're not taking that into account. And the server is a better place for you to do a lot of this stuff. And you don't need to do that in JavaScript. Again, SEO heavy websites, websites that rely on SEO, that need the page to be loaded on first load, is another really good indicator where you can probably lean towards less JavaScript for the site. If you have a marketing page with a bunch of SEO heavy titles and stuff like that, that should all be rendered in HTML. So the server should be doing the actual compilation of all those things. Or you just have an HTML file, that's fine too. Intense background processing. We mentioned the video situation, right? So if you have something that you need to intensely, like YouTube, for instance, a lot of those videos are transcoded on the server and then probably given to you on the client. So anyone can view those videos. It doesn't matter how bad your computer is. For the most part, your computer can still view the video because a lot of the heavy lifting is done by the server. And that can be done with massive calculations, like I mentioned before. That can be done with any sort of intense work that needs to be done. You can offload that to the back end. That shouldn't usually be done on the front end unless you're running into some cost issues. When you can't rely on a client device, so we mentioned this again, a client, you don't know what they're going to have. Are they going to have a phone from 10 years ago? Are they going to have a Chromebook that's $200 that's barely put together? If you can't rely on their client's device and you need everyone to be able to access your application, then you need to offload as much as you possibly can to a server. This is a very good indicator for you to, hey, I need to offload more and more of my JavaScript to the server, because if this user on a $100 phone from 10 years ago can't click this button, I'm not able to access that demographic, or I'm not able to serve that demographic when I'm building like a government website. Government contracts or government websites really rely on accessibility. You need to be able to make sure that anyone can access it from any sort of location that's feasible, right? Like if they're from doing slow 3G from the forest, they still need to be able to submit a form to be able to, get their driver's license. That's really important information to know when choosing where to do the processing. And the biggest one, and probably the most important one, or the most important two really, is when you're doing secure data. So when you're doing authentication, or when you're accessing an API with an API key, that shouldn't be accessible to anyone. All of that needs to be done on a server. So if you think about it, most applications, any application that really has a login, which is like all of them, they require a server. All of that server stuff, that can be done in any language. It does not need to be JavaScript. You don't need to do it in JavaScript. And any sort of, again, any sort of sensitive data that you need to pass through, passwords, government documents, anything, that should all be done through a secure server connection, never through the front end. The front end is only handling the secure connection between the front end and the server. Any sort of processing, any sort of storage, any sort of access or database access, all has to be done on the server. And dealing with the user's files, the front end can do very rudimentary things. It's kind of like in a sandbox where you can kind of upload a file to a front end manually by dragging and dropping or something like that. But the front end can't technically access your file system. So if you need someone to like open up an Explorer, or you need to access someone's like C drive to do something crazy, or you need to access someone's pictures to do something, you can't do that with just a front end application. So if you need access to a user's file system, you have to use a server connection. There's no other choice. And again, any backend language can access a file system. You don't have to use JavaScript for that. I think there's probably many more that I didn't list here. I'm not going to keep going. The list can probably go on for a long time, but I think you get the idea that I've mentioned a lot what you can do with JavaScript on the front end. I've mentioned a lot on the back end, what you need to use the back end for. The real conclusion here, to kind of sum it up, is to make a good application, you're going to have both. There's no argument here. There really is no argument. If you're building a web development application, no matter how much you hate JavaScript, you're going to need to use it in some capacity to make a better user experience. It's just the reality.
Yeah, there comes a point when you have to realize that, I mean, there are different technologies for a reason. I mean, there's pros and cons of each. And I mean, use the tool for the job. We've said that several times. Use the right tool for the job. And like, I mean, that effectively sums that up. If you try to use something that isn't right for the job, I mean, there's going to be inefficiencies. And if you're doing it just because you're like, well, I said I wasn't going to use servers, so I'm only using front end. It's like, well, I guess you're not having authentication then. You know, there's just foolishness. You need both for stuff.
There's no point in arguing. The argument can be fun, I guess, if you're actually, interested in arguing. But yeah, JavaScript's not perfect. So isn't any other language. Like Ruby is definitely not perfect, I would say, 100%. It's a good language. Nothing wrong with it, but it's not perfect in any way, shape, or form. PHP, not perfect. It's fine. It's a good language. Not perfect. None of them are perfect. Like there is no perfect language. Now, some say that Go is really good. Like I haven't tried it yet. I understand. Okay, I'll try Go. I heard it's really good. It has like a mix of all the languages. It's like easy to write, has type safety, has memory management. That if you want it, you don't need to use it. Like it's all kind of, it sounds really cool. But again, like it probably still has deficiencies. Like it's probably not perfect. And it is a newer language. So they had the learnings of all the older stuff before them. They were able to kind of clean sheet it and make something completely new. And that's awesome. I love that. And I hope that more languages come out of it, like more, even better languages and even better languages. But the reality is that those languages can only be used in certain situations. They can't be used on the front end. Like you cannot use Go in the web browser, period. You have to run it on the server and then hope that it works. And that's it. Like, yeah, I don't know. It's just, I'm hoping from this episode that you understand why it's important to learn both the front end and the back end, why you can't rely on one or the other to be a good full stack or even like a web developer in general, right? Like you need to at least understand what's happening on the back end because of what I mentioned before. And you need to understand what's happening on the front end. If you're a web developer that's only doing back end, you need to dive into JavaScript a little bit. It'll make your app better. Like, yes, HTMX can do it. HTMX can do a lot, right? HTMX is making it easier for a backend developer to touch JavaScript without touching JavaScript because it abstracts a lot of it. Like it's still, HTMX is a JavaScript library. I want to be clear here. It's just making it so that you don't have to touch it. Like it's abstracting the JavaScript away, and that's great. Good. Like for certain little things, for like pressing a button and incrementing, that might be okay for most applications. But for applications that rely on quick responsivity, that need to have good interactivity, that are like interactive across multiple levels of UI, it's not a silver bullet. It's not a silver bullet. You still need to write some JavaScript. Like it's not a big deal. Like if you're a good backend developer, I guarantee you will wrap your head around JavaScript quickly and become sufficient enough to make good UIs with it.
Yeah, like unless you specifically know what you're going to be building, there's tons of people out there that make their living exclusively on like certain builders like Webflow or Elementor or things like that. Like unless you know specifically what you're doing. But I mean, that is a good point. Even in there is that you are pigeonholed to a certain extent. And so if the client, requests something that is outside of there, then, you're kind of toast unless you hire someone to help or you have to direct them somewhere else. And that's not to say you should know everything either. Like, I mean, my client can ask me, we had a client ask us what the tax law was for charities. Like, don't ask your web developer that. There's some things that are just, I'm not going to learn that. I'm not going to learn that to tell you. You're going to have to go to an accountant or some sort of financial professional for that. But it really is another tool in the tool chest, if you will, where if you want to build really extravagant projects, then I don't want to say you can't, because I'm sure someone has an example of them doing this, but you can't just completely sort of say, that's it. Like these technologies are on the block list. You can't ignore and block, certain things. I mean, I say that when I don't use Mac, but I mean, at the same time, Mac and Windows are pretty close. So like, that's probably a fair enough thing to say no to, but no, that's exactly it. Like it's versatile enough. Like, and like, I mean, Audacity is on Mac, but it's also on Windows, right? Like the operating system is not abstracted. I can't really think of the word at the moment, but the operating system is general. Like both a Mac OS and Windows are general use. So obviously, like generally things will work on them. But that's my piece for the end of it. Like, I mean, use the right tool for the job. Make sure that you do that. If you want big extravagant projects, make sure that you like learn, multiple things and try to be open to technologies. And if you hate something, and it's for a good reason. You know, Mike and I have things that we are just like, Jesus, like I really don't want to use that. Great, you know, then don't use that. Like Mike and I are not the biggest fans of Joomla, but there's people out there making money on Joomla. There's people out there developing Joomla. Like that's an example of that. Absolutely, like 100%. Fair enough. I mean, that's why there's different agencies. That's why there's various options, and that's why there's competitors. I mean, absolutely. So we all don't have to be on the same page.
Absolutely. I think it's even more so with programming at this point. I think if we were all on the same page, it would be kind of boring as well, where like we wouldn't have innovations. Like no one would make another language because they'd be like, oh, this is fine. I'm glad that there are arguments, but I'm also glad that some people take that argument and are like, hey, maybe we should just make something better instead of just complaining about it all the time, right? Like I'm okay with the complaining sometimes because it makes for interesting content and interesting conversations, but also there's a lot of people out there that are just building things that are better, which is awesome.
Yeah, otherwise we'd all still be on like WordPress 1.0. Be like, man, we made websites. Websites are complete. What's the next thing, right? It'd be a totally different field instead of an iteration and an evolution of the existing field. But I think that's it. That concludes this episode, unless you have anything else to add, Mike. Well, remember that if you want to support episodes like this, you can do so on Patreon. That's patreon.com/HTML. All the things. And many thanks to our $3 tier patrons. Tim from the Web Hacker on thewebhacker.com. Jason from Geek Life Radio via geekliferadio.com. Garrett Segal. Level Up Financial Planning via www.levelupfinancialplanning.com. Joshua via silvio.us. And Magnus from YesWeb via yesweb.se. Remember, we also have a Scrimba affiliate link if you want to learn on their interactive media player code editor. We have a Scrimba affiliate link that will be in the show description as well as in the show notes on htmlallthethings.com. It may be a discount code. We're working on that with Scrimba right now because they're upgrading their website. And those details of a discount, if it exists, will be on htmlallthethings.com in the show notes. And last but not least, we'd like to give a shout out to Michael LaRocca, a contributing author on htmlallthethings.com. Michael is the author of Self-Taught, the X Generation blog at selftaughttxg.com. Feel free to leave a comment or a review on the platform that you were listening to this on, and this outro will sign us off.
You've been listening to HTML All the Things podcast. Web development, web design, and small business. We hope you've gotten some useful and practical information from this show. And we hope you appreciate that we talk to you like human beings. And we hope you had some fun. We'll be back soon. But in the meantime, hit us up on social media. On Facebook, Instagram, and Patreon at HTML All the Things. And on Twitter at HTML Everything. Until next time, this is HTML All the Things, signing off.